What you have to find fun, right? There's when it gets down to the area formulas with arc length and the area of the triangle stuff, what I want you guys to be able to do is find the arc length, area of the sector, and then if you had to, an area of a triangle. But it's not going to be a problem where it's just going to throw right at you. So find the area of this triangle given, the two sides, and then you conclude an angle. It might be tacked onto like a law of sines problem or a law of cosines. They'll throw in there as well. Also, if you think back to the law of sines, law of cosine stuff, remember when you had all those different categories to worry about with the law of sines? If you had an acute angle or you had an obtuse angle? The easy scenario was if you had an obtuse angle, then you only had to worry about two different cases. When you had the acute angle, you had to worry about, what, 4 of them? And possibly the double triangle awesomeness? Well, on the test tomorrow, if you have to use law of sines and the angle is acute, it will work right away. You don't need to worry about it. If the angle is obtuse, you only have to worry about checking those two categories, okay? If the side opposite is too big or is smaller or larger. That way you don't have to worry about those extra 4 parts. All you need to worry about would be law of sines with an obtuse angle. Remember, the larger side has to be across from the largest angle. It's a very easy thing to visualize. Draw the picture. If it doesn't show up to work right in the picture, it doesn't work. It's that simple. Okay? You can't do it. Does that make sense? All right. Now, when it comes down to the rest of the stuff, let's just start going through. Was there anything in particular, as far as the actual homework itself, from those handful of problems? I'm pretty sure most of you guys flew through those on Friday when we were in here. Which one? 60? That was 13-2, right? Radius is 3, theta is pi over 4. Find the arc length and the area. So, radius is 3. Radius is 3, and theta is pi over 4. When I want to find the arc length is just going to be the radius times theta. When I want to find the area, it's going to be 1/2 3 squared times theta. When you multiply that out, you get 9 over 2, and that winds up being 9 pi over 8. And then 2-inch ice cream. Over 9 over 8. And I use the ice cream reference because you work at Ollie's. It's not ice cream. And our son spilled that all over himself. Whenever you guys buy a car, top tip of the day, there is a company called WeatherTech. They sell floor pan liners. They're very expensive, but they cover every square inch of carpet underneath your car. I have a Suburban, so I have 9,000 square feet of carpet inside my Suburban. It's a savior with small children and a dog. I don't want it. There's spilled water all over it. But it stayed in the pan itself. She opened it up and dumped out the gallon of water she decided to spill. And it saved my carpet. What's that?
Decided?
Just her water bottle wasn't shut. So when you purchase a vehicle, especially when you have small children, order those floor pan liners. Put every square inch of your car, make sure it's covered. Top tip of the day. Not. Then don't buy it. What other questions do you have?
67.
I know, just the random things you guys get to learn in here. Isn't it just awesome? 16 and 50. 16 is your radius, and it's 50 degrees. So we have to convert that into radians, because everything has to be in radians. So you multiply it by pi, put it over 180. So you get 5 pi over 18 is your theta. Okay. And then just use the formulas. Your arc length was radius times theta, so it's 16 times 5 over 18 pi. So it's 8, so it's 40 over 9, 40 pi over 9. And then the area, it's going to be 1/2 of your radius squared times theta, which was 5 pi over 8. 256 cut in half is 128. 128 times 5 times pi over 8. I can divide both of those by 4, and I get a 2. Oh, wait, I can divide them both by 8. 8 goes in here. 1, 4, 14 times 5 is 70 pi. Something squared. Told you it was going to be easy. And you were worried. I remember that. Make sure your names are on those, pass those up. Those should have been pretty simple. Let's discuss some of that chapter review stuff. What's that? I can't hear you. Good. If you're going through these review stuff, some of the first things you're going to notice is how you're doing basically the exact same thing with questions worded differently. Now, what I'm going to do here is kind of reference back to the actual chapter review versus the quiz that you took and show you guys how it's very easy to have one thing mean something and go a different route with another one. But if you're all still doing the same stuff. So let's start with evaluating the 6 trig functions of theta. So let's say we're looking at number 4. It says find what are all the possible 6 trig functions for theta given that right triangle. Well, one of the things you need to realize is that whenever you're given a right triangle, that means it's the easy stuff. Cheap soap and toilet that you probably didn't even try. Okay? That's all it is. When you're given the right triangle to start with, find the hypotenuse and go. You'll notice 5, 12, 13. It's a triple. If you forgot some of the triple stuff, just use Pythagorean theorem, you'll still get the answer. Now, when you're dealing with right triangle trig, it's just good old soap and toilet. And just fill it in. Sine, 24 over 26, which is 5 over 12 over 13. Cosine is 10 over 26, which is 5 over 13. Tangent, which is 24 over 10, which is 12 over 5. Those are all your common soap and toilet stuff. The cosecant stuff just goes through, and you cosecant, secant, and cotangent, you just inverse all of those. You flip them. So your cosecant is your 13 over 12. The secant is 13 over 5. And the cotangent is the 5 over 12. Okay? You didn't need to do anything else with those. So you didn't have to rationalize any denominators. It was very straightforward, plain old boring soap and toilet. Plain old boring soap and toilet, straightforward, solve right triangle, boom, done. Now, on the quiz, the next question had to deal with the ladder. Now, when you're dealing with the ladder stuff, now what happens with the ladder problem, there are still some of you guys that seem to forget, when you have a 12-foot ladder, that's as high up as the ladder can go. If by chance you had a negative answer or your ladder was reaching 28 feet up in the air, in the back of your mind, you probably ask yourself, I'm probably doing something wrong. remember guys, take a second, look at your answers, and say, does it make any sense at all? Okay? Sometimes you guys do something silly and you just don't even think about it because you get so ingrained of tunnel vision. Oh, I gotta get this done. Oh, I gotta get this done. Please stop walking your dog. And you forget to ask, does it make sense? Okay? So just slow down every once in a while and think about it. Also, when you go back to the quiz, there was another question on there. It said cosine of theta is 5/7. What is everything else? Now, that's when you have to switch your brain and go, all right, I'm given one of the values. What does it mean? When I'm given cosine of theta is a fraction, remember, cosine of theta, when you start writing this stuff out, it's x over r. Then you have to figure out what is y. Remember, r squared is x squared plus y squared. You fill in the blanks, and you solve for y. That way you can figure out what sine is, because remember, sine is y over r. Cosine is x over r. Tangent, y over x. You flip everything around. Cosecant, secant, cotangent. Okay. When you do that, you wind up with 49 is 25 plus y squared, which means the square root of 24 is y. You have to simplify your radicals. A lot of you guys forgot to simplify radicals. That's 4 and 6, so it's 2 root 6. Okay. Now it's a matter of just substituting in. You know what x is, you know what r is, and now you know what y is. It's just a matter of just filling them all in. The only ones you have to really worry about is when you have that radical in the denominator itself, because you have to rationalize it. For example, if I'm looking at the cotangent, that's going to be 5/2 root 6. The only thing you have to do to rationalize that denominator is multiply the top and bottom by root 6. So you wind up with 5 root 6 over 12. Remember, square root of junk times the square root of junk is junk. That's where I'm getting 12. You're giving me scrunchy face.
I was just getting that falling out.
2, what, root 6 times root 6 is 6. 6 times 2 is? Pretty easy when I see scrunchy face. Same thing with cosecant, you got to rationalize your denominator. A lot of you guys didn't rationalize or you simplify your fractions incorrectly. Now, if you flip to the back side of the quiz, there was another problem on there that said an ordered pair. And then it asked you what was the cosecant, I think? I think that's what it gave you. Is that right? And was that the ordered pair, negative 3, 3? Okay. Now, once again, this is very similar to the other two style problems. You're given the ordered pair. You know that the ordered pair is x and y. You also know by now that the ordered pairs, you can find r. Oops, not equals r. You can find r by just squaring these two together. Take the square root, and that gives you r. Negative 3 squared plus 9 squared is 18. Square root of 18 is 3 root 2. Once again, you got to simplify your fractions. Okay. What's that?
That was the
Oh, was it cosine? Okay, I wasn't sure. I know it was one of those. Now, I can't say that the cosine of theta here is negative 3 because I'm not on the unit circle. Okay? I'm at a point with a terminal side. That means you can create the right triangle. Okay? So now you know what your r value is, and you know cosine is x over r. So you have negative 3 over 3 root 2, which gives you, ladies and gentlemen, that root 2 just doesn't automatically float north when you simplify that. Negative 1 over root 2, where you get negative root 2 over 2. Some of you guys were floating it north. They can't just float north. All right? It's not on the mighty Kish. Kish floats north, right? Doesn't it? When you go under Bethany, it flows north. Just not its mouth. Okay? So when you see ordered pairs in this, you're still going to find the R value and go. Okay? Does that make sense? Now, the other parts on here, let's steal this blue one real fast before I go back and forth. The rest of this on here was fairly straightforward until you get into the last two questions. Those last two questions deal with inverse functions. Now, when you're dealing with the inverse function, first one says sine of theta is negative 0.62. Is that right? And it's asking for it the angle in the third quadrant between 180 and 270, correct? So that means what this is asking you on the unit circle, when you have to figure out what the sine is, what two quadrants are you looking for theta when you're looking for sine? First and fourth. So the angle is going to show up here. That will allow me to figure out what the reference angle is. And I want to figure out where theta is here. Okay? So what I do here is I have to go to my calculator. I start with degrees because it's giving me theta in terms of degrees because it's telling you look in between 180 and 270. Make sure I'm in the mode of degrees. Inverse sine, negative 0.62. Hit enter. I get an angle measurement of negative 38.32. Okay. So if I have an angle measurement of negative 38.32, what's the reference angle for that? Well, 38.32. How far away is it from the x-axis? Your reference angles are always how far are you from an x-axis. All right, it's always the shortest distance between the x-axis. So if I want to be in happy land here, I'm going to have a reference angle going in of 38.32. So how do I figure out what this full theta is? Now I add 270. How far is this off of 180? You add 180. So it's 180 plus the 38.32. That gives me theta. Okay? That's how you come around. It's the same idea when you're dealing with the tangent. Okay? It's the same idea for the next question when you deal with tangent. I believe it said tangent of theta was 3.2. Is that correct? And then it's also third quadrant it's looking for. Okay. So first, once again, you start out by figuring out what angle has a tangent 3.2. Second tangent 3.2, hit enter. And I have a degree measurement of 72.65. Oh, remember, tangent's also in first and fourth quadrant. Tangent and sine are first and fourth, cosine is first and second. So there's my reference angle for that. I want to be in the third quadrant, so once again, I just recreate here, add 180 to it, and I'm in the third quadrant. Okay, forget that. It's all about reference angles. Other than that, the calculator portion of the test, remember there's calculator, non-calculator. The calculator portion of the test is very straightforward. Okay? You know, calculate and do these little bits and pieces here and there. Now, when it comes down to the non-calculator part, that's when everything boils back down to your friend and mine, the unit circle. Which means we have to be able to recreate the unit circle the easiest way possible. The easiest way possible to recreate the unit circle is to start in the first quadrant. Or you can always do it this way. I just cut it into fourths, right? 45, 90, 135, 180, so on and so forth. Remember, this was pi over 4. 1/2, so it's pi over 2. Remember the trick when you're going up by fourths? 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. Okay? All you did then was just simplify your fractions. You did the same thing. 30, 60. Every 30 degrees, how much of a fraction did you go up? 1/6. So you had 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, and everything has a pi. I just didn't simplify my fractions. Okay. That's the quickest way around the circle. Simplifying the fraction part's the easy part. Also, after that, what's the trick for your ordered pairs? 3, 2, 1. 1, 2, 3. And numerators are all square roots. And from that, it just mirrors itself around. It just mirrors itself through for the rest of them. Okay. Now, what will happen on that non-calculator part then, it's going to ask you, well, what is the sine of 3 pi over 4? Well, I figure out where 3 pi over 4 is. I figure out where 3 pi over 4 is, and I'm looking for the sine. When you're looking at your ordered pairs, that's when it goes cosine and sine. So at 3 pi over 4, well, it mirrors that one. It's just negative and positive, so it's negative root 2, negative root 2 over 2, and root 2 over 2. So what's the sine at 3 pi over 4? Root 2 over 2. Okay. In the third quadrant, they're both negative. In the fourth quadrant, it's positive, negative. It's just a matter of figuring out which reference angle it is and spinning through it. Okay. I believe in the review stuff, it says tangent of 11 pi over 4 was one of the questions. What's the tangent of 11 pi over 4? Well, the first thing you got to figure out is where is 11 pi over 4? Well, how many times does 4 go into 11? Twice. How many are left over? 3/4. So I start by going around the circle. 1 pi, 2 pi, and 3/4 pi. So I'm back there. If I want to find the tangent, how do you find tangent? Y over x. So tangent's y over x, or sine over cosine in this case. Since sine and cosine are the same, just with alternate signs, what's tangent? It's -1. Everybody okay with it just being -1? Since it's root 2 over 2 divided by root 2 over 2, it's negative. Everything simplifies out, you get -1. It's all about being able to spin around the circle until you find out where you are. Okay. Let's see. The other one on here is secant 225. Secant 225. Well, figure out what quadrant is 225 in and how many degrees. Well, obviously, it's 180. Add in a 45. Excuse me. So the secant of 225 is down here at 5 pi over 4. The ordered pair, well, it has a reference angle, as you can see again, of root 2 over 2, root 2 over 2. Well, what do you know about both sine and cosine here? They're both negative. Negative? Made of a name. They're both negative. If I want to find the secant, then, the secant, well, that's the inverse of what? Cosine. Cosine here is negative root 2 over 2. So the secant would be negative 2 over root 2. What do you have to do now? Simplify it. Yep. Multiply top and bottom by root 2. And I get negative 2 root 2 over 2, otherwise known as negative root 2. Just by simplifying out. Okay. That's how you're finding those angles without knowing where you are, or by using radians and stuff. When you're working backwards, like on numbers 19, 20, through those guys, the first one it says, what is the inverse sine of root 2 over 2? Well, that means you start by figuring out what angle has a sine of root 2 over 2. Well, sine has a positive root 2 over 2 here at pi over 4, otherwise known as 45 degrees. You'll have to be able to do both, radians and degrees. Okay. Tangent of root 3 over 3. This is one that a lot of people tend to have issues with. I want to do tangent inverse of root 3 over 3. Well, last time I checked on the unit circle, there's nothing that says root 3 over 3. So I got to figure out which one it's going to be. I know I can throw out all values of pi over 4 though, right? I can throw out all values of pi over 4 because they're all root 2's and root 2's. And since tangent is sine divided by cosine, y over x, what I want to do here is just take a guess. I'm going to try either at pi over 6 or pi over 3. Does it matter which one you choose to try first? Nope. Let's try pi over 6. So 1/2 divided by root 3 over 2. Simplify it out. You get 1/2 times 2 over root 3, which is 1 over root 3, otherwise known as root 3 over 3. I got lucky. The first one I tried, it's pi over 6. Let's say it didn't work here. What does it have to be then? The other one. It's going to be pi over 3. Okay? There's no rhyme or reason. It's just a guess. Yes, ma'am? Oh, it's going to look exactly like that. What is this? It's going to ask you just that. And it'll say find the degree measures in theta, or find theta in both radians and degrees. Okay. If you look at your pink sheet, it'll look like 16 and 17 and 18. It'll look just like those. All right, it'll look just like those. On the chapter review, bless you. On the chapter review, there are problems like that. 19 through 23 are like that. Okay. What's the cosine inverse of 0? That means it's asking you what angle has a cosine of 0. When you have a cosine of 0, that means it's probably one of the quadrantals, because that's the only ones that have zeros in them. When cosine is 0, that means that the x value is 0. The x value is 0 either at 90 or 270. But when you're trying to find cosine, what quadrants are you looking in? Between, I should say. I'm looking between first and second. So that means I got to get 90 degrees, otherwise known as pi over 2. Everything else on here, guys, is going to be extraordinarily straightforward. There's not going to be anything that's going to trick you. It's going to be very similar to the way the layout was on the quizzes themselves. Calculator, non-calculator. Be sure that you are using your time wisely. Okay? Don't put off that non-calculator part because you got stumped on a problem. Push, push, push. You know. Remember, halfway through the period in this class, what time do we start? We start at Maybe we start at 10 after, we start at 5 after, and we're done at 52. So if you're not at the Don calculator part by about 12:30, well, you've got time. Okay, just to help yourselves pace it. Okay. Are there other style in here in that chapter? Do you want me to re-go over with you at all? Now, today I have to go get my boys after school because I have a meeting at the Ed Center. But tomorrow I'll be here again in the morning, usually by 10 after at the latest. So if you guys have questions first thing in the morning as well. Okay. Yes, ma'am.
Something like 4 on the calculator part.
Positive and negative coterminals. On 4, it gave you, find one positive, one negative coterminal angle for 111 degrees. So what happens here is that if this value is between 0 and 360, you add 360 to it, you subtract 360. That's it. So since this is within one revolution, it's over here to start with, all you do is you add 360 to figure out where you wound up, and you subtract 360 to figure out where you wound up. If it is at, let's say, 411, the positive one, since it's already past 360 degrees, you would subtract 360 right away to start with to figure out the first positive, and then what do you get? You get 51 degrees. There's your positive coterminal, and then you subtract again to get the negative. Okay? That's the only time you have to subtract twice. Or sometimes you might subtract more. You want to be within one revolution to start. Okay? Not going to be any tricks here, guys. No reason to trick you.